Next, we have four colligative properties for a dilute solutions. That is, first one is relative lowering of vapor pressure. Second one is elevation in boiling point. Third one is uh, depression in freezing point. Fourth one is osmotic pressure. Okay, so remember that point. Why we have these colligative properties? Because if you add a non-volatile solid to volatile solvent, its vapor pressure decreases. Okay, here if you add a non-volatile solute to a volatile solvent, clear? Is a solution of, if you prepare a solution of a non-volatile solute with volatile solvent, then vapor pressure decreases. Vapor pressure of the solution decreases. Yeah, that is because of non-volatile nature of the solute. Okay, so this decrease in vapor pressure, that will give some specific characteristic to the that given solution. Okay, so because of that we have that four properties. Okay, that four properties based on the decrease in vapor pressure of the solution while adding non-volatile solute to the volatile solvent. Okay, now we have four colligative properties. First one is relative lowering of vapor pressure. Second one is elevation in boiling point. Third one is depression in freezing point. Fourth one is osmotic pressure. We'll discuss first one, that is relative lowering of vapor pressure. Okay, name says lowering of vapor pressure. What it means? If you add a non-volatile solute to volatile solvent, its vapor pressure decreases. Okay, that is the meaning of relative lowering of vapor pressure. That means if you take a solvent, let its vapor pressure, let it be Pa naught. Okay, that is a pure solvent. Its vapor pressure is Pa naught. Okay, then let vapor pressure of solution, that is equal to P. Okay, this is vapor pressure of solution. This one is vapor pressure of pure solvent. Then clearly shows lowering of vapor pressure. That means when you add non-volatile solid to volatile solvent, vapor pressure decreases. That clearly shows vapor pressure of the solvent is more than that of a solution. You can write vapor pressure of a solvent is more than that of the solution. That is the meaning of lowering of vapor pressure. So remember this point. When if you add a non-volatile solid to volatile solvent, its vapor pressure decreases. It means what? Vapor pressure of the solution decreases. Okay. Then last class we discussed one derivation, right? That is the final expression xi b equal to, okay, Pa naught minus P divided by Pa naught. Okay, xi b equal to Pa naught minus P divided by Pa naught, where xi b is mole fraction of solute, that is mole fraction of solute, then Pa naught is, that is vapor pressure of solvent. Pa naught is vapor pressure of solvent. Then Pa is vapor pressure of solution. Vapor pressure of the solution. Okay. So there's the expression for relative lowering of vapor pressure. Okay. Relation between mole fraction of solute with the lowering of vapor pressure. Then one more term, that is a numerator term, that is Pa naught minus P. Okay. Numerator term Pa naught minus P, that is called as lowering of vapor pressure. Lowering of vapor pressure. Pa naught minus P is called lowering of vapor pressure. Nothing but what is Pa naught here? Vapor pressure of the solvent minus vapor pressure of the solution. That difference is called lowering of vapor pressure. Okay, vapor pressure of solvent minus vapor pressure of solution. That term is called lowering of vapor pressure. Remember point, that is lowering of vapor pressure is not a colligative property. Remember, lowering of a vapor pressure is not a colligative property. Okay, here lowering of vapor pressure is not a colligative property. Okay, then here you can observe Pa naught minus P, vapor pressure of solvent minus vapor pressure of solution. Value is positive. That clearly shows vapor pressure of the pure solvent is always higher than that of the solution. Next, the whole term, that is Pa naught minus P divided by Pa naught. Okay, that whole term Pa naught minus P divided by Pa naught, that is called relative lowering of vapor pressure. Relative lowering of vapor pressure. Relative lowering of vapor pressure. That whole term is called as relative lowering of vapor pressure. Pa naught minus P divided by Pa naught, that is called relative lowering of vapor pressure. So we can write the definition of relative lowering of vapor pressure as it is the ratio of lowering of vapor pressure to vapor pressure of the pure solvent. Yes or no? Pa naught minus P is nothing but lowering of vapor pressure. Pa naught is vapor pressure of the pure solvent, and that ratio is called relative lowering of vapor pressure. So we can say it is the ratio of lowering of vapor pressure to vapor pressure of the pure solvent. Okay, yes, it's about expression for relative lowering of vapor pressure. Then important point is relative lowering of vapor pressure is a colligative property, because relative lowering of vapor pressure depends on the number of solid particles present on the solution, but not on the nature of the solid particles. Okay, yes. Next, if you refer some other textbooks, okay, if you refer NCERT textbook, okay, uh, they will take a solvent as 1 and a solid as 2. Okay, you will get expression like this: xi1 or xi2 or xib, that is xi2 equal to p1 naught minus p divided by p1 naught. Okay, this in NCERT textbook we have expression like this. Okay, then some other textbook, if you refer Jivit publication book, they are taking it as xib equal to pa naught minus pa divided by pa naught. Okay, here some textbook, while taking that relation, we are taking p instead of p, we are taking it as pa. Okay, here also sometime instead of we are taking as p, we are taking p1. What is p1 actually? Vapor pressure of the solution. That is because in case of, that is p total equal to, we are writing it as pa plus pb, right? P total equal to Pa plus Pb. What is Pa? Partial vapor pressure of solvent. What is Pb? Partial vapor pressure of solute. But you know, you are taking non-volatile solute, right? You are taking non-volatile solute. So P equal to Pa, right? P equal to Pa, because Pb value is equal to 0. Pb value is equal to 0. So P equal to Pa. Okay, so either you can take this expression xi p equal to Pa naught minus P divided by Pa naught, or you can write this expression xi b equal to Pa naught minus Pa divided by Pa naught. What is P and Pa here? P and Pa are nothing but vapor pressure of solution. Okay, vapor pressure of solution. Confusion ಬೇಡ ಅದರಲ್ಲಿ. Okay, some textbook they're just mentioning it as P, some textbook they are mentioning it as PA. Okay, because P is equal to PA. Here P is equal to PA, nothing but P and PA are nothing but vapor pressure of the solution. We go for next topic, that is in case of relative lowering of vapor pressure, that is calculation of molar mass of solute. Okay, molar mass of solute. Calculation of molar mass of solute using relative lowering of vapor pressure. Using relative lowering of vapor pressure. Using relative lowering of vapor pressure. Okay, xi b equal to Pa naught minus Pa divided by Pa naught, right? Xi b equal to Pa naught minus Pa divided by Pa naught. Okay, this is the first expression. Okay, nothing but relative lowering of vapor pressure is equal to mole fraction of the solute when solvent only is volatile. Okay, then xi b equal to, what is xi b? Nothing but mole fraction of the solute. Here we are taking B as solute. So xi b equal to expression for mole fraction Nb divided by Na plus Nb. Okay, this is the expression for mole fraction of the solute xi b. Xi b equal to Nb divided by Na plus Nb. Okay, then what is Nb? What is Nb? N means what? Number of moles. How to calculate number of moles? Number of moles equal to weight of the solute Wb, weight of the given component divided by its molar mass. That is how to calculate the number of moles of the solute. Already ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿ ಆಗಿದೆ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಅನ್ನು ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ಅಂತ. ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಅನ್ನು ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು, ಎಷ್ಟು ವೆಯ್ಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಡಿವೈಡೆಡ್ ಬೈ ಆ ಸಾಲಿಡ್ ನ molar mass, so that will give number of moles. Okay, so here nb is nothing but number of moles of solute, that is equal to Wb, weight of the solute divided by its molar mass. Weight of the solute divided by its molar mass. Then Na, what is Na? That is Na is nothing but number of moles of solvent. Okay, remember one point. A means solvent. Okay, B means solute. ಅದು ಅದುವೇ ಆಗಬೇಕು ಅಂತಿಲ್ಲ, ಜನರಲಿ ನಿಮ್ಮ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಹಾಗೆ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾರೆ. ಓಕೆ, ಎ ಅನ್ನು ಸಾಲ್ವೆಂಟ್ ಅಂತ ತಗೊಳ್ತಾರೆ, ಬಿ ಅನ್ನು ಸಾಲ್ಯೂಟ್. ಸಿಂಬಲ್ ಯೂಸ್ ಟು ರೆಪ್ರೆಸೆಂಟ್ ಸಾಲ್ಯೂಟ್ ಅಂಡ್ ಸಾಲ್ವೆಂಟ್. ಓಕೆ, ಸೊ ಎನ್ ಬಿ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ ಸಾಲ್ಯೂಟ್. ಎನ್ ಎ means nothing but number of moles of solvent. Okay, then Na equal to Wa divided by Ma. Wa divided by Ma. Okay, Wa divided by Ma. Then substitute these two expression here in equation number. If you take this one and substitute that two expression in equation number 1. Okay, then one more point we can write Na plus Nb is almost equal to Na. Then substitute here, we are writing xi b equal to Nb divided by, what is the meaning of Na plus Nb? It's almost equal to Na. Okay, so we can write that is equal to Na. Clear? First you have to take this expression, that is a relative lowering of vapor pressure. Next you have to go for what is the meaning of xi b. Next you have to write what is the meaning of Nb and what is the meaning of Na. Then this term Na plus Nb, it is almost equal to Na. Then substitute these two datas here. We are getting xi b equal to Nb divided by Na. Then substitute that values. What is the meaning of Nb? That is equal to Wb divided by Mb. Wb divided by Mb. Okay, then what is the value of Na? Na is nothing but Wa divided by Ma. Wa divided by Ma. Okay, Wa divided by Ma. Then xi b equal to Wb into this MA goes to, not MA, that's MA, that goes to numerator. Okay, so that will become MA, okay, divided by this MB, that denominator, into WE, right? That is the value of xi b. Okay, xi b equal to WB into MA divided by MB into WA. Okay, next take it as equation number 2. Take it as equation number 2. Substitute equation number 2 in this. Okay, let's take it as a star or something. Okay, substitute 2 in this one, first expression. Okay, substitute 2 in first expression. Substitute that 2 in first expression. Yes, what we'll get? What do you have to calculate actually? That is the problem, right? ಈಗ ಏನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂತ ಗೊತ್ತುಂಟಾ? ಎಸ್, ಯು ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ MB. ಓಕೆ, ಇಲ್ಲಿ ಆಲ್ರೆಡಿ ಬರೆದಿದ್ದೇವೆ, ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಆಫ್ ಮೋಲಾರ್ ಮಾಸ್ ಆಫ್ ಸಾಲ್ಯೂಟ್. MB ಇಸ್ ಮೋಲಾರ್ ಮಾಸ್ ಆಫ್ ದಿ ಸಾಲ್ಯೂಟ್. ಓಕೆ, ನೀವು ರಿಅರೇಂಜ್ ಮಾಡಿ MB ಗೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಏನು ಬರುತ್ತೆ ಅಂತ ನೋಡಿ. ಓಕೆ, what is meaning of xi b? That is nothing but WB into MA divided by MB into WA, that is equal to PA naught minus PA divided by PA naught, right? WB into MA divided by MB into WA, that is nothing but xi b equal to PA naught minus PA divided by PA naught. Then just rearrange, you have to get the value of MB. Okay, ನಿಮಗೆ MB ಯ ವ್ಯಾಲ್ಯೂ ಬೇಕಾದ್ದು. So MB equal to, just take this to here. Okay, then come bring this complete term to denominator. Okay, MB ಅನ್ನು ನ್ಯೂಮರೇಟರ್ ತಗೊಂಡೋಗಿ ಇಲ್ಲಿ complete term, that is a relative lowering of vapor pressure ಅನ್ನು denominator ತಗೊಂಡು ಬನ್ನಿ. So that we'll get MB equal to WB into MA, WB into MA divided by WA into WA into completed term, that is PA naught minus PA divided by PA naught, right? MB equal to WB into MA into WA divided by this complete term, or we can write MB equal to WB into MA into this PA naught divided by WA into PA naught minus PA naught minus PA. Okay, MB equal to WB into MA into PA naught divided by WA into PA naught minus PA. Yes, that is the expression used to calculate molar mass of the solute. Okay, using relative lowering of vapor pressure. Explain the terms. What is MB? That is a molar mass of the solute. MB is molar mass of the solute. MB is molar mass of the solute. MB is the molar mass of the solute. But this formula, that is a 3 mark compulsory problem ಬರ್ತದೆ based on this formula. Okay, you have to buy at this formula. ಓಕೆ. ದೆನ್ ಜಸ್ಟ್ ಫಾರ್ಮುಲಾ ಕಲ್ತ್ರೆ ಸಾಕಾಗೋದಿಲ್ಲ, ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು ವಾಟ್ ಆರ್ ದಿ ಟರ್ಮ್ಸ್. ಓಕೆ, ಕನ್ಫ್ಯೂಷನ್ ಮಾಡ್ಕೊಂಡು ಪಿ ಎ ನಾಟ್ ಪಿ ಎನ್ನು ಆಚೀಚೆ ಮಿಕ್ಸ್ ಮಾಡ್ಲಿಕ್ಕಿಲ್ಲ. ಓಕೆ, ಯು ಹ್ಯಾವ್ ಟು ಬೈ ಅಟ್ ದಿಸ್ ಫಾರ್ಮುಲಾ, ಅಲಾಂಗ್ ವಿತ್ ಇಟ್ ಯು ಹ್ಯಾವ್ ಟು ಬೈ ಅಟ್ ದಟ್ ವಾಟ್ ಆರ್ ದಟ್ ಟರ್ಮ್ಸ್. ಓಕೆ, ಎಸ್. MB is molar mass of the solute. Then we have WB. WB is weight of the solute. WB is weight of the solute. WB is weight of the solute. Solute, weight of the solute. Next, MA is there. MA is molar mass of solvent. Molar mass of the solvent. MA is molar mass of the solvent. MA. Next we have WA. WA is the solvent. Okay, weight of the solvent. A is solvent. Okay, that is weight of the solvent. Next ಬರ್ಕೊಳ್ಳಿದು, what is PA naught? PA naught is vapor pressure of the pure solvent. PA naught is vapor pressure of pure solvent. PA is vapor pressure of the solution. PA is vapor pressure of the solution. Okay, clear? MB equal to WB into MA into PA naught divided by WA into PA naught minus PA, where MB is molar mass of the solute, WB is weight of the solute, MA is molar mass of the solvent, MA is molar mass of the solvent, PA naught is the vapor pressure of the pure solvent, vapor pressure of the pure solvent. Then WA, that is a weight of the solvent. PA naught is vapor pressure of the pure solvent. PA is nothing but vapor pressure of the solution. So ಈಗ ಫಾರ್ಮುಲಾ ಗೊತ್ತಿರ್ತದೆ, ಕನ್ಫ್ಯೂಷನ್ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕಿಲ್ಲ. A is for solvent, A for solvent, that is B for solute. Okay, A ಅನ್ನು ಯಾವುದನ್ನು represent ಮಾಡುತ್ತೆ? that will represent solvent. B, here we are using B to represent solute. Okay,